new class. We continue discussion of set theory. Now we have universal set. Universal set of a given set A is the set of all elements under consideration. We will see example. A is the set 1, 2, 3, 4. Universal set of A can be taken as 1, 2, 3, 4, 5, 6, 7. Or somebody else may take universal set as the set of natural numbers 1, 2, 3, 4, 5, etc. Now this set N can also be represented by set builder form. This is called the set builder form. X such that X is in N, the set of natural numbers. You see, this is the set builder form. Or N can be written as 1, 2, 3, 4, 5, etc. And this is called the roster form. So we see a set can either be represented by the roster form or by the set builder form. In the set builder form, we explain the behavior or characteristic or the nature of the elements. In roster, we write down all the elements. Now, complement of a set A, another important idea. Complement of a set A is U minus A denoted by AC or A bar or A dash. So that A dash is U minus A. Clearly, A will be U minus A dash. Complement means you take the universe and remove that set. If you have A, you remove A, you get the complement. Now we consider an important idea. Euler-Venn diagram. It is a method of representing sets. Here, the universal set is represented by a rectangle. You can see a rectangle. That represents the universal set. And sets by circles in the rectangle. In the figure you see, set A is represented, set B is there, set C is there. Now, this part is common. Common part is the intersection of A and B. So we see A intersection B is the area like this. Now this is A and we remove B. So this is A minus B. Now A minus B means you take A and remove anything that comes in B. So this part is A minus B. Now we can see it is A intersection B bar. Because this is B, the whole balance is B bar. So one part of A and the intersection of B, outside B. Outside B, that intersection means common part. So that becomes A intersection B bar. Similarly, this is B minus A. Now C has nothing to do here. Now A union B can be taken as the union of this and this. So it is A intersection B bar, union A intersection B, union A bar intersection B. Now A minus B is important, is A intersection B bar. A is A minus B union A intersection B. This is A minus B, this is A intersection B, the union produces A. Now in this figure you see, universal set is there, A is here, so balance outside is A dash. Actually A dash is U minus A. This is the complement of A. So this is A, the outside is U minus A. Now we require all these considerations when we discuss more problems. Let us see. Now we consider the universal set, set A, set B. Now region 1, this is not the number 1, just simply the region 1, region 2 and region 3. Now there are N1 observations in this region, N2 observations in this common region, N3 observations in this region and N4 in this region. So we see the universal set contains the regions 1, 2, 3, 4, and the number in the universal set is n1 plus n2 plus n3 plus n4. Now you can see that A is represented by the areas 1 and 2, B is represented by the areas 2 and 3, A union B is represented by the areas 1, 2, 3. Now n of A union B, number in A union B is NA plus NB minus NA intersection B. This is important. Now number in A union B, the whole of this is A union B, this part. It is N1 plus N2 plus N3. Now number in A is N1 plus N2. Number in B is N2 plus N3. Number in the intersection is N2. Now when you add N1 plus N2 with N2 plus N3, you get 2 times N2. So you have to remove 1 time. The result is N1 plus N2 plus N3 is actually N1 plus N2 plus N2 plus N3 minus N2. And that result is NA union B is NA plus NB minus NA intersection B. Now clearly we see N of A union B is less than or equal to NA plus NB because we are subtracting something from NA plus NB. So this fellow will be less. So NA union B is less than or equal to NA plus NB. Now we see if A and B are disjoint, there is no common factor. A intersection B is the null set, therefore number in the null set is 0. So that in that case, A union B is simply NA plus NB. Reason A intersection B is 0. Now we consider 2 important results. A union B intersection C. B intersection C bracket. A union B intersection C is A union B intersection A union C. You can see A union is coming. Now this property is union is distributed over intersection. You can see one U, one intersection on the left side, but there are 2 U, and only one intersection. So union is distributed over intersection. Now when you say A into B plus C is A into B plus A into C. A into is coming. Now there is 1 into and 1 addition. 1 multiplication and 1 addition. Here there are 2 multiplications and 1 addition. So multiplication is distributed. This multiplication is distributed over addition. Such a property comes here. Union is distributed. Similarly, A intersection B union C is A intersection B union A intersection C. That A intersection will come always together. Intersection is distributed. Now for a proof, you have the Venn diagram. A is represented by the areas 1, 2, 3, 4. B 2, 3, 5, 7. C 3, 4, 5, 6. And outside it is 8. Now you can see B intersection C, common for B and C is 3, 5. And A union B intersection C is 1, 2, 3, 4 together with 3, 5 gives you 1, 2, 3, 4, 5. Now A union B intersection A union C, this side is 1, 2, 3, 4, 5, 6, 5, 7. Intersection 1, 2, 3, 4, 5, 6. Answer is 1, 2, 3, 4, 5. So they are one and the same thing. So we see A union B intersection C is A union B intersection A union C. Now we need only apply simple results. We apply A intersection B, A union B, etc. and get the result. So this diagram shows the answer. All of you, we will continue this lesson in the next course. I would like to thank you for attending closely. Make sure that you work out at home. You work out along with your friends. You can convey this message to your friends so that many will be benefited. My aim is to give you the simple ideas. Mathematics is a simple thing. I want to give you simple ideas by simple examples. Thank you very much. Best of luck.